Metal fabricating is not what it was 30 years ago. The technology has changed it very dramatically. Hi, my name is Steve Heim, and today we're in the facilities of Brenco Industries. Brenco is a provider of cutting, forming, and fabricating solutions to the fabricating industry. We're going to have a look at how the technologies have changed very dramatically, where they are now, and possibly what they're going to lead to. One thing we know for sure is that this industry is not standing still. Technology and job opportunities will continue to grow and develop as time goes on. This is a garden hose. The water pressure coming out of it is about 80 psi. Behind me is a water jet cutter. The water pressure being used in that machine is 60,000 psi. The table size on this one is 8 feet by 40 feet. It's one of two machines that we operate at Brenco Industries. Water jet will cut through virtually anything: steel, stainless steel, mild steel, including granite, and even glass that's 2.5 inches thick. The thickest material that this machine will cut is 6 inches of anything. 60,000 psi is a lot of water pressure, but we don't use a lot of water. Each of the two cutting heads behind me uses about 5 liters of water a minute and about a pound or half a kilogram of garnet every minute. The advantages of water jet cutting is that it cuts just about everything. The disadvantage is that it is an expensive process. The maintenance is very high on the machinery, and the consumables are expensive as well. But there is a place in the market for this kind of machinery because it'll do what laser and plasma cannot do. Water jet, plasma, and laser are all programmed at an office workstation. By programming, we mean the machines are told what to do. They're told what to cut and in what sequence. The operator is ensuring that the machine is doing what it's been told to do and that the cut quality is consistent and accurate. This 4x8 sheet of 3/8 aluminum was cut with water jet. 450 parts came from this piece, and they're all tabbed in so that once the plate comes off the table, the pieces are pulled out by hand and ready to be shipped to the customer. So you've seen that water jet is a great process for cutting a lot of different materials, such as this aluminum in front of me. But there are other processes such as plasma and laser, and each has their own special application. This is an 8-foot by 24-foot high-definition plasma table. It is controlled by a computer, and the output are parts of various sizes and shapes. You can see that things don't have to necessarily be square, but they can be round as well. Accuracies are close, not as close as they can be because we have other machinery for extremely high tolerances. But we're going to start this machine up, and you can have a look at what it looks like and what it does. Think of plasma as a lightning bolt. This is very high voltage electricity being pushed through the metal to melt the material with compressed gas. This high definition plasma is being operated by a controller, being controlled by a computer. At one time, this part would have required various processes, shearing, punching, in order to make this finished part. On this piece of material, we're cutting approximately 60 parts, and we're going to cut this in 30 minutes. At one time, with manual processes, this would have taken many hours to make these same parts. When you were a kid on a summer afternoon when the sun was out, you probably sat on a sidewalk with a magnifying glass and started to burn little pieces of cardboard. Well, that's what a laser does. It focuses light energy into a very fine point, hot enough so that it melts metal and cuts it away. And it is able to cut such fine detail as a piece like this and cut it to within accuracies that are almost immeasurable, thousandths of an inch. These machines are very complex and yet are also designed to operate lights out. Lights out means that an operator can come over, start the machine, walk away from it, and it'll continue to operate. However, the skill level in operating one of these machines is very high. A lot of training is required to be a good laser operator. Operating equipment like lasers requires an understanding of the cutting process, and that is all about education. It's learning how these machines operate. There are various cutting parameters on a laser. and you have to know what each one does and how it behaves so that when you're analyzing a cut, you know what needs to be changed or adjusted to improve the cut quality. These are examples of hollow structural steel weldment utilizing 1-inch thick plasma cut steel and laser cut 1/8 steel. Press brakes. They've been around for a long, long time. It's an old technology that's been made new with computerization. The tooling used on these machines is precision ground. It's very, very accurate, which allows the operators to produce parts that are formed to a very close tolerance. That makes the fabricator's job a whole lot easier because he doesn't have to use the hammer to make parts fit anymore. The technology in these new press brakes not only makes for a higher quality product, but also simplifies the operation. No longer is forming a black art, but in fact it is now a skilled trade. This machine not only forms things very accurately, but helps the operator in that it's going to show him the sequence of bends that he has to perform. Modern lasers include time-saving features such as ruby lasers for locating the center of the punch. This saves the operator a lot of time and a lot of trouble in setting up his job and making that bend accurate. Automation is having an impact on welding as well. Let's take a quick trip to Prince George to see what's happening.
Yeah, this is a robotic welding cell we brought in a number of years ago. It is definitely the future of a part of our business. What that robotic welding cell does, it welds repetitive pieces, essentially, as simply as I could put it. So when we have high precision, high tolerance pieces that are very difficult for a human arm to manipulate and to get the same every single time, we employ our robotic cell to do that work.
All these technologies that you've seen have actually been around for a long, long time. It's been the advent of the computer that has really made these all viable. The ability to control these technologies very, very accurately and to do it efficiently is really what's been happening in the last few years. And the technologies continue to improve. Water jets become more powerful, lasers become more powerful and more automated, and the plasma cutting becomes finer and finer in its quality and detail. There's no end to where this technology is going, and you can see from where it's come from over the last even 30 years that there's a long way to go. But nonetheless, this is a great technology, and it has saved thousands and thousands of man hours every year in this shop alone in being able to cut very accurate and high quality parts. There is a notion that the increase in technology and efficiencies will put people out of work, and nothing could be further from the truth. The ability for machines like this laser to produce parts that are as of high quality as this, as accurate as they are, in fact changes metal fabricating. No longer are we operating with big square rudimentary pieces of metal and putting them together, but in fact we're producing parts that are very complex and unique and create a whole new opportunity for parts to be made out of metal. Innovation that creates new engineering and new concepts and new designs. There is no end to where this technology is going to take metal fabricating into the future. Today you've had the opportunity to look at how the technology is changing in the metal fabricating industry. Not only is the technology changing, but career opportunities are continuing to evolve as well. This is an industry that's not standing still, it's continuing to grow and develop, and guaranteed it's going to look different 20 years from now than it does today. Thanks very much for joining us today. We hope you found this time to be valuable.